So after the data has been collected, we got our subjects. We got our subjects. Um, we've collected data. What the heck do we do with it? We typically will input the data using statistical software. The main ones I should have put up there Excel too is SPSS, StatView, and these other two. But we're going to use Excel. You actually have a learning activity this week that you need to use Excel. It's got enough power that we can email it back and forth, so I can actually run the data on it for you and email it back to you and hopefully explain what the numbers mean. So, and this is a picture here on the left hand side of what SPSS looks like. Whatever we collect has to be turned into numbers, regardless if it's nominal or ordinal data. It's got to have numbers associated with it. The nice thing is the statistical software will calculate all the statistics. We don't really need, you guys don't need to understand the math behind the statistics. What you need to understand is what the numbers mean. And I hope to teach you that next week on some of these other procedures. What do those numbers mean? What's in the long run, what's it mean? In part one of this lecture, I was trying to teach you, I'm hoping that during a learning activity, you'll understand what that study did and what the end results mean. In the textbook, I use the terminology inferential statistics. The textbook uses some different terminology, but it means this pretty much the same thing. The textbook talks about parametric and non-parametric statistical tests. Parametric statistical tests are based on, we talked about the normal curve. Again, there's that normal curve. What parametric statistics is based on is that pretty much there's a normal distribution that can fit into this curve that we have. We can say, generally speaking, the data we're going to collect fits into this nice pattern, and so that way we can compare groups of individuals to one another based on this normal curve. Whereas non-parametric statistical test is based on where this distribution, this normal curve, is not there. It's not the same as this at all. And so we have to do different statistical procedures for that. And we'll talk about that in next week on some of those tests. Now that we're on the normal curve, there's a couple things that we need to be reminded of. Again, what this normal curve represents is a theoretical distribution of data. We can say we collect data, it should look like this. And it does, actually. If we have enough numbers on the same sample of a group of individuals, a population, generally speaking, when we graph the numbers, it's going to look like this. Again, it suggests that the data is symmetrically distributed around our mean, the mode, and a median. And as you can see, it's bell-shaped. I kind of went over all this already, so I'm not going to spend any more time on that because we talked about it at the last lecture. A couple little things I want to talk to you about is skewness of data. I had talked about with means. Means are affected by extreme numbers. So, for example, the picture or the graph on the left-hand side, letter A, shows that the data is skewed more to the left. That means all the values are skewed on the negative side of the mean. So we have smaller numbers. That's going to change our means. It's kind of throws off our values. Whereas on the other one, the B, graph, all the values are skewed to the right or on a positive side of the mean, and that just changes the numbers. They're not equally distributed. We have some extreme values. Now, by looking at the pictures, kurtosis is telling us that now the values are affected by not numbers to the left or the right of the mean, but high and low. The A1 shows that the numbers are elevated up, and the B graphic is showing you that the numbers are lower than normal distribution. The textbook goes in a little bit more detail on this. Just want to give you the highlights on that. And our last thing I want to talk to you about is what the heck's all this mean? What's it tell us? Who cares? Statistics, the techniques really tell us, significance of the effect. Did whatever we do in our research or in our study, did it really do what we hoped to do? We set out to, like for example, we talked about my study with a null hypothesis of there'll be no significant differences between novice and experienced athletic training students that are enrolled in an athletic training education program on professional socialization measured by a specific test. I needed to survey athletic training students, then I had to run a statistical technique to see if there was significantly difference. Were novice and experienced athletic training students, were they different from one another? Only way I can do that is through these statistical tests. Other one is the strength of the relationship. Was there even meaningfulness to the data that I collected? Did it really mean anything? Was it weak? It was just hodgepodge. It doesn't really mean anything to us. Another thing that statistics help us with is well, there's going to be different types of techniques. We're going to talk about next week about the relationship among variability. That's another fancy way of saying correlation or relationships between the variables. Does variable X have a relationship to variable Y? Does X, smoking, have a relationship to cancer? Okay, that's the thing that we're looking at. Other thing we can do is we can tell the differences among groups. Again, novice athletic training student is one group, experienced athletic training students is another group. We can compare if these groups are different, and we can do different groups like that. The textbook does a really good job talking about cause and effect. Correlation is no proof of causation. What is meant by that? Smoking does not cause cancer. Smoking is related to cancer, but it's not the direct cause. People who don't smoke still get cancer. Okay, there's a relationship. You have a greater risk of having cancer if you smoke, but that's not a direct causation or cause for cancer. The book does a good job about that, talking about that. So we're done with this second part of chapter 6. What you need to do is read chapters 7 and 11 and read the material in Blackboard and the E lectures. I did not do a podcast for those two lectures. There's the thing on chapter 7, what I want you to focus on is the things I highlighted in Blackboard, which are just briefly understanding what predictability and alpha power mean. And on chapter 11, the things that are important there are reliability and validity. What are the different ways to determine that? That's going to be important, the validity and reliability, when you report reliability and validity for questionnaire or any kind of instrument that you're going to use. That would be important in your Chapter 3. Chapter 11 also discusses the different scales that you can use for like your surveys or questionnaires and those type of things. So it's good information. Another thing you need to do is complete the learning activities. This week you had part 1 where you're working as a group, working through that research scenario that I've given you. Part 2 is you're going to upload the Excel spreadsheet and run some data on that. I've tried to give you a written explanation on how to do that. So if you have any questions about that, you can ask that question on the Q&A discussion board in Blackboard. And good luck, and talk to you later.